End of May, 2026. If you have been doing AI engineering for more than 2 years, you grew up reciting Sutton's bitter lesson like a creed. Scale wins. Hand-engineered features lose. General methods that ride compute beat clever tricks every time. That was the right lesson. It still is, at the frontier. But somewhere between late 2024 and the spring of 2026, the lesson got more interesting in production. 4 frontier capability, open-ended reasoning, multi-domain agents, coding across an unknown stack, scale still wins. Nothing close. But for the work most of us actually ship, narrow tasks, latency-sensitive paths, cost-bound deployments, small fine-tuned models are crushing frontier ones. That is the reversal. Not Sutton was wrong. Sutton was right about the asymptote. We just stopped paying attention to where production lives. Production lives far below the asymptote, very close to the cost and latency floor. And down there, the rules are different. Let me trace how we got here, because the curve looks linear from inside it. 2022 to 2023, the GPT-4 era. The advice was simple. Call the biggest model you can afford. Prompt engineering was the entire stack. If a task did not fit, you waited 6 months, and the next model fit it. 2024. Open weights catch up. Llama 3. Mistral large. Qwen 2. The gap to GPT-4 narrowed from generations to months. Self-hosting became a real option for engineering-led teams. But fine-tuning was still painful. Tooling was rough. Benchmarks favored the bigger model. 2025. 2 things changed quietly. Distillation got cheap. Llama tooling matured. The labs themselves started shipping distilled production lines. Anthropic's Haiku. Mistral's small line. OpenAI's Mini and Nano. Google's Flash and Nano. Distillation went from research curiosity to default ship pattern. Every flagship now has a small sibling trained on its logits. Llama tooling matured at the same time. Axolotl. Unsloth. Modal templates. RunPod recipes. A real engineer with a GitHub account and a credit card could go from I have a task to I have a fine-tune deployed in an afternoon. Early 2026. The inversion is now visible to anyone running production AI. A 50-clip fine-tune costs about 50 cents of compute. A frontier model call costs around $30 per million output tokens. On a narrow task with a stable distribution, the fine-tune wins on every axis production cares about. Cost, latency, privacy, IP, predictability. Frontier still wins on capability ceiling. But you do not always need the ceiling. You almost never need the ceiling. This is the reversed bitter lesson. At the frontier, scale wins. In production, narrow beats general. Let me make this concrete with one story I keep returning to. I call it the Omni voice anchor. A friend ships a niche product. Voice cloning for a regional dialect spoken by maybe 3 million people. Frontier voice models do not cover this dialect. Not because the labs are hostile. Because the data is not there, and the market is not big enough to justify the curation. He has 50 audio clips. Total. Around 40 minutes of speech. He fine-tunes a 1.5 billion parameter open voice model on those 50 clips. On a spot GPU. Total compute cost. 50 cents. Total wall clock time. Under 4 hours. Most of which was him eating dinner while the loss curve dropped. The result. Production-grade voice synthesis for a dialect no frontier provider offers. 50 clips. 50 cents. 4 hours. Production. That is the reversal in a single anecdote. There is no frontier model for this problem. A small fine-tune is the only answer. And it is also the cheapest, the fastest, the most controllable answer. This did not happen by magic. For specific technical advances stack to make small models a serious option. 1. Distillation. Train a small student on the logits of a large teacher. The student does not learn to be a great general model. It learns to imitate the teacher on the data you actually care about. A 7 billion model distilled from a 405 billion teacher matches the teacher within a percentage point on a narrow domain. 10 times faster. 50 times cheaper. 2. LoRa and QLoRa. Low-rank adapters. Freeze the base. Train a tiny rank decomposed edition. 0.1% of the parameters. 16 gigabytes of GPU memory. 4 hours. You are done. Stack adapters per task. Hot swap at inference time. 3. On-device. RAM became the new VRAM. Apple Intelligence ships a 3 billion local model on every recent iPhone. Google's Gemini Nano runs on Pixel and a long tail of Android. Phi-4 fits in 8 GB on a laptop. The on-device model is no longer a science demo. It is the path for any feature that needs no network, no per-call cost, full privacy. 4. Task-specific small models. The unsung one. Sentiment. Classification. Structured extraction. Intent routing. Entity recognition. Content moderation. A 1 to 3 billion fine-tune routinely beats GPT-4 class Frontier by 5 to 15 points on the task benchmark, while costing roughly 1,000th as much per token. Not comparable. Better. By a lot. If you are a senior AI engineer in 2026, for pressures push you towards small models whether you wanted to go there or not. Cost. Frontier API pricing is dropping, but not fast enough for high-volume use cases. 100 million calls a month at $30 per million is a P&L disaster. Latency. The speed of light still works. A round trip from a European user to a US data center is 60 to 100 milliseconds before the model has done anything. An on-device 3 billion, or an in-region 7 billion, is often under 20 milliseconds end-to-end. For voice, for autocomplete, that is the difference between magic and laggy. Privacy. Healthcare, finance, defense, legal. None of them can ship customer data to a US cloud provider. They have to self-host. Self-hosting a 7 billion is reasonable. Self-hosting a 400 billion is a six-figure decision. Control. A fine-tune produces deterministic structured output the way a prompt cannot. If you need every response to match a JSON schema, every time, with no drift, you fine-tune. Prompts plus retries are a worse engineering answer. IP. Your prompt is a string in a config file. Anyone who sees your traffic sees your prompt. Your fine-tune weights are yours. They embed your data, your edge cases, your formatting, your domain expertise. They are a real moat. Prompts are not. Draw the choices on a 2D plot. Capability on one axis. Cost plus latency on the other. For clusters appear. Frontier models. Top right. Highest capability. Highest cost. Highest latency. Worth it when you need the ceiling. Agentic coding, open-ended reasoning. Open weight medium with retrieval. Upper middle. Strong general capability. Moderate cost. Moderate latency. Fine-tuned small. Far left, high on the relevant capability axis. Domain narrow, but on their domain they match or beat the frontier. Latency low. Cost negligible. On-device 3 billion. Floor of cost and latency. Capability is task-dependent. For the right task it is plenty. The mistake every team makes. They treat this as a one-axis chart. It is two axes. The right model depends on where the task lives on the map. A fine-tune is operationally heavier than a prompt. There are real cases where it is the wrong call. Skip fine-tuning if your task changes weekly. The point of fine-tuning is to bake a stable distribution into weights. If the distribution shifts faster than you can retrain, you are paying ops cost for nothing. Skip fine-tuning if you need world knowledge. A small fine-tune does not know about last week's events. Use a frontier model with retrieval. Skip fine-tuning if you have fewer than 50 examples and no synthetic data plan. Below that threshold, prompts beat a fine-tune that has not seen enough signal. Skip fine-tuning if your latency budget allows API calls and your volume is low. The ops burden is real. 10,000 calls a month? Use the API. The flip side. You should fine-tune when these conditions hit. The task is narrow and the data distribution is stable. You need a domain-specific style or format that prompting cannot reliably hit. Your monthly Frontier API spend exceeds about $1,000. You need on-device or sub-100 millisecond latency. Compliance requires self-hosting. Any one of these is enough. 2 or more, and it is malpractice not to. If you are starting today, the path is well-trodden. 6 steps. 1. Pick a base. Llama 3.18 billion. Qwen 3, 8 billion. Gemma 3, 12 billion. All strong. All permissively licensed. All well supported. 2. Generate synthetic data. Use a frontier model to produce 200 to 500 high-quality examples in your target format. The part that used to be hard. Now routine. 3. LoRa fine-tune on rented GPUs. Run pod. Model. Lambda Labs. For hours. About $5. Axolotl or unsloth. Default hyperparameters are usually fine. 4. Evaluate against the frontier on your held-out set. This is non-negotiable. If you do not eval, you're guessing. Your fine-tune should match or beat the frontier on your task-specific benchmark. Otherwise something is wrong. 5. Deploy via VLM, TGI, or Llama. Containerize. Auto-scale. Point traffic at it. 6. Stack adapters. Next variant of the task? Train another adapter on the same base. Hot swap at inference time. In 2026, the savvy AI engineer owns a fine-tune pipeline. Not because frontier models are bad. They are extraordinary. But they are the calculator. Fine-tunes are the spreadsheet. The calculator is more capable per operation. The spreadsheet is what runs the business. You need both. The one you do not have right now is probably the spreadsheet. The bitter lesson said scale wins. It still does, at the frontier. The reversed bitter lesson says, in production, narrow wins. Both are true. Knowing which lesson applies to which problem is the new senior engineer skill.